we are starting super fine. So I'm Maite Giménez, as I said. I'm a PhD student at the UPB, but you don't care about that. We are going to have fun and learn some things. So first of all, I want to, before introducing what are neural networks, I want to give you a little bit of my motivation to be here explaining what is this deep learning without gibberish. We have tons of toolkits right now. We have the summer of deep learning, and people are using deep learning blindly. So we truly need to understand what's happening inside our algorithms in order to be able to do cool things with that. So you're going to need to know what are deep neural networks properly. So I said that I'm going to explain deep learning without gibberish, but they might be some gibberish, but deal with me. Okay, so what are neural networks? Neural networks are a machine learning algorithm, and why is working right now? We have tons of data that we don't used to have, and mostly we have way faster computers. So these are not new algorithms at all, and they have been with us for a really long time. However, we are starting to have the technology to develop them, which is cool. So what are an MLP? A basic neural network. They have like three main parts. The input, the data that we are learning from, the hidden layers. The hidden layers are just a linear combination of the inputs with a nonlinear function, and the output nodes. It's similar to the hidden network, hidden nodes, okay. It's a layer similar to the hidden layer, but we are getting an output, a prediction. So yeah, we need data labeled in order to train this model. And the basic example of the model is the XOR door, which we have 3 inputs, and we want to figure it out what is the output of the network. So this would be the system. We have our 3 inputs. It's working, okay. Yeah. Okay, so these are our I1, I0, I1, I2, because engineers start counting on 0. And this is the hidden layer. And what we are going to do is have a combination of the inputs in this point, which is multiplication, basically. And then we are going to combine these nodes in an output. So yeah, I said then I want answers at the end, but please interrupt me if something is not clear. Good? Yeah. So we are in a PyCon. I'm going to explain how to do it in Python, obviously. So first of all, I have tons of OCC, and I urge you to do it also. Have a Conda environment, a virtual env, I don't care, but have separate environments for doing experiments. So I have created my environment, obviously in Python 3. If you're not working in Python 3, please leave the room. Okay, so yeah, I style the basic. This is the most basic neural networks that you're going to get. NumPy and Jupyter. I don't need anything else. And let's see if we can go. We have a lovely GIF first. We are going to learn artificial neural networks. Sorry, I interrupted just for the GIF. So, okay. Yeah, I'm going to be here. What do we have? What we said that we need and what we have. We have a nonlinear function. In this case, it's the sigmoid. It's just, I have an input. I'm going to do it with it, yeah. Can you see I have an input, and and I'm going to return this nonlinear function, okay? And if I want to do the derivative, so yeah, I forgot to say something before. So we have 2 phases in the neural networks. We have a phase that goes up, the forward phase, and a phase that goes back, the backward phase. So the forward phase, we do the nonlinear function, and then we get an error. When we get this error, we propagate this error to the later layers. How to do it? With the derivative of the previous layer. So it's super easy. Is it? I'm losing you all? OK, at least you breathe. OK. So what does this function do? We have a set of data, and the nonlinear is, OK, given a point, I'm going to give you a nonlinear representation. It has an interesting property, then it collapses in 0 and 1. But I cannot manage to do the graphic. Oh, what did I do? OK, cool. Cool. So let's dig in. I said then we are going to have 3 inputs that are, do you remember these 3 inputs from the XOR node? And this is my prediction. So for this input, I want this output. Cool? Cool. I guess you're alive. So what are these connections? These green connections are just a matrix of weights. We have a bias, but I'm going to, yeah, you have these inputs plus the bias in order to try to handle several problems, and I'm going to leave out of the scope of this talk. So we have this matrix for this first hidden layer, and then we have this other matrix for this other hidden layer. So the edges of the graph are matrices, easy peasy. OK, so this is the algorithm. This lines of code is a neural network. How awesome is it? So we have the forward phase, where we get the input layer. We get the dot product of the input layer with the weights of the first layer, and we get the hidden layer. And then on the output layer, we get the weights of the hidden layer, then we just compute, and the weights of the output, the other half of the graph, and we get the output layer. Cool. So with this output layer, we compute why was the true result. So we compute which is the output error. And yeah, this is apprend. So and we want to get delta. How bad was it? How much I want to change the previous layer in order to improve on the next phase. So I get the delta with, can you see, the derivative is true, so I'm getting the derivative of the output layer. And I propagate it, the hidden layer, and update the weights with these deltas. And then that's it. So you have learned in 9 minutes how to create a neural network. And can you say this is the output? So the error we can see then is download getting lower. And at the output after training, we get these results. Then if we round it, we can see, OK, it's pretty close. It's pretty close? No, it's exactly the same. OK, it's exactly the same as the expected output, which is super cool. But this is the simplest problem of them all. Did you have any questions? Because I really need you to understand this properly in order to move forward. I have a hater section, but for the other one, I really need. OK, I'm going to assume, since you don't speak, then you understand greatly what I'm explaining. So, OK, so I said, then this is neural network. OK, cool. Please, 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 load. But what are the difference between a deep learning algorithm and a neural network algorithm? Well, tons of people don't have clearly the barrier. Maybe we haven't established properly, but deep learning algorithms have several things. No. OK. when you're down there and you see people getting problems with the slides, like, come on, guy, have you prepared this better? But yeah, it's hard. OK, so what is the difference between a neural network and a deep learning algorithm? Firstly, we need to have learning representation. So the hidden layers had to learn a representation good enough for the output layer to be able to classify your input. And in a neural network with one hidden layer, we don't have a learning representation. We only have inputs and outputs, and a combination, linear combination with a nonlinear function. More thing than we need. Deep learning, since we have said that we need to have learning representation, we don't want to do pre-processing. If we are doing pre-processing, we are establishing some bias. And the idea is that we have a neural network complex enough in order to model the system. And yeah, more data. More data is vital. It's vital for everything. And much more hidden layers. So basically, we need more data, more hidden layers, and do not touch things too much. Cool. And this is the objective of my talk, basically, this section. So a lot of people said, OK, neural networks are bio-inspired. Come on. If someone of you shows me a paper that my brain is doing derivatives right now, I will buy him or her a beer. But it's not what our brain is doing. But it's great for marketing. So yeah, machines are not going to conquer the world. Be relaxed, don't worry. We are not there yet at all. This other thing that bothers me tons. This is a true slide of a deep learning course. So this is a simple neural network, as I previously presented. And if you put 3 more hidden layers, it's a deep. Come on, dudes. It could be cooler if I hadn't to run. This is a deep learning model. Can you see the difference? Yeah, and it's a deep learning model from 2014. So models right now are, I don't have slides. We need all the projectors from the room. So this is deep learning, not. So another thing that bothers me, and in my tutorial I have done this. So since we need so much data, we are not going to do dev set. Dev sets are the set of data that you use to tune your system. So you need to not use this set of data to train, because otherwise you're cheating. So since people say, OK, I really need a lot of deep learning, a lot of data for training my deep learning model, it's like, OK, I'm going to use all the data and then tune it in training. Science is broken if we do that. And the cult of deep learning. So right now, there's a lot of, and we have seen here, tons of talks of deep learning. But this is only a branch. There's a lot of other ideas, a lot of other methods. So please be aware that this is not the absolute truth. And if someone tells you that, they're lying to you. Science is always doubtful. I doubt every time. So if you met a scientist who is super sure what he's doing, doubt of his science. And my favorite one, deep learning is magic. And my answer is, hell no, deep learning is science. So yeah, it's a stochastic science. So we have a little bit of noise, but it's mostly science. OK. The deep learning gibberish. So this I'm going to, first of all, I'm going to say I was wrong. So this is a simplification. Previously, 10 minutes previously of my slide, a lovely gentleman explained this to me, and I say, OK, fuck. So let's say this is a simplification, but we use a lot of tensors. As you can see, one of the most popular libraries is Tensorflow. And people from deep learning, I used to think that tensors are like, OK, it's an array, but in more dimensions. It's not. But you can use this assumption if you are doing this thing, but be aware that this is not the truth. And I'm going to update it as soon as I get to understand it properly, because, yeah, I don't want to do what other people do to the science. So I said that there is a nonlinear function. And normally, the nonlinear function, in order not to just multiply the inputs with a weights and get the output, because that's nothing, we need a nonlinear. The one that I show you in the notebook is the sigmoid. But in deep learning, we usually use this ReLU, this rectifier linear unit. Why we use this? There's a really good reasoning behind this. They're faster to train. Dot. That's it, period. We don't. Actually, I have a really horrendous problem with these ReLUs because they have mathematical problems in the backward phase. So be aware that since you are going to see tons of tutorials of deep learning that use ReLUs, but you need to understand what the ReLUs are doing, and yeah, you can use whatever other nonlinear functions. Actually, please use them. I will be super happy if you propose another nonlinear function outside of these 4 ones. That are the only ones that we use. The kitchen. I talked a little bit of the kitchen before. And we have these hyperparameters, like how many how many networks nodes we put in the hidden layers, how many hidden layers we put, and we have to be super clean with doing this. We need a set of data that we haven't seen previously in order to be able to express what we are doing, and if we are sure, because yeah, we can prove in a lab that our system has 90% of accuracy, but what happens in the wild? So yeah, science have to check this thing. And the toolkits, and I'm going to skip them all because you have seen it. But yeah, Python is cool. Why? Because ideas are complex. I have explained super briefly the ideas, but we don't need the code to be complex. If you've seen this neural network in CUDA, it's hard. And we want to create better models, complex model, but not complex code. And I'm going just to list this. We have Cyano, is the older one. You can install it with Conda. This is all a lie. You have an example, you're going to check it. The Tensorflow is the most, it's one of the cooler ones because you have lower level abilities. You can get a lot of things. But the learning curve is a little bit tougher. So yeah. Keras is super cool, but you need to have installed either Cyano or Tensorflow. It's really cool. If you want to play, actually the demo, then I'm not sure if I'm going to have time to do it, is in Keras. And the new kid in the blog is PyTorch. It's developed by Facebook. And I want to include it because when you see the slides at home, yeah, check it. Because they have this cool, super cool thing. Then you can define a computational graph that defines the neural network that I have created previously. And you can change it during the training, which is interesting for some applications. And convolve, my friend. Yeah, cool. So, what are convolutions? Our brain don't have convolutions. Our brain doesn't have kernel. Sorry, I was checking this time. Doesn't have this kernel, but basically is okay. Instead of having a huge neural network with a huge weights in each of the hidden layers, why don't we learn a tiny one and then we apply it through the whole thing? It's very used in image because it's natural and have some properties and are very good for image. It sounds like the local invariance. And this is the only slide with gibberish, I promise to you, but I needed this. So you have this image, and we have this kernel. Those are matrices, and yeah, it's just the application. And when you're learning the kernel. Things that the key term of the CNNs are the number of kernels, how many kernels do you want to use, this stride, how do you want to apply. So I'm going to move 1 point, 2 points, 3 points, 3 nodes in the matrix, and the size. But I'm running out of time. Yeah, and this is the example of CNN. So we have an input of a curve, we apply these kernels to a point, and we move forward. We have a convolution, and then a ReLU, because if we don't put a nonlinear function, we only have a linear combination of the inputs, and it's absolutely nothing. And then you put an MLP. It's exactly the same MLP that I have explained in the first slides. OK, so I'm going to use text. And in text, we make a super trick. OK, I'm going to imagine that each word is an array of a matrix. And we build this matrix. And yeah, the Bechdel test. Great. So the Bechdel test is a test that you need to know. So you need to know two things. Learn your inputs, learn what's under the cover of the neural network, and the Bechdel test. So Bechdel test measures if there's 2 women in a movie, if the 2 of them talk of something that are not men, and yeah, that's it. So you can imagine that all the movies in the world will comply, pass the Bechdel test. So not only 57% of the Bechdel test, the movies pass the Bechdel test, and interestingly, they receive less budget and they get more revenue. So yeah, we need to start addressing issues. This is not going to happen. And yeah, I'm going to show you super fast an example. So, OK, we have pandas and keras. We love pandas. They need contribution, so if you want to share love, go ahead. And we love this, the data from the movies, and also the movies is the if they pass or not pass, or do not pass the Bechdel test, and the data from the EMD. So we have a lot of things, blah, blah, blah. And yeah, I have the plot, and I want to get to know if they pass or they don't pass the Bechdel test. So I do a lot of things to get ready this, a lot of tricks, blah, blah. And yeah, I want to go here. And I'm going to get finishing. So I want to show you just to stress how super easy it is to define a convolution in keras. So if you know what you are doing, it honestly took me 3 hours to do it, the whole thing, and I don't write keras. So you can do it also. But you need to know your basics. Yeah, you can get what are the architecture of your network. And if you have used scikit-learn, you know this gibberish fits the model with the training data and evaluates the data. And doing this super out-of-the-box algorithm, we get a 62% of accuracy. And that was all of my talk. So please, guys, give me questions, or I kill you all. Tell me.
You said that a tensor is not just a multidimensional array?
It's not.
So what is it?
You need to address Pablo Galindo later. So yeah, maybe Pepe also? Yeah, later you can. Yeah, but yeah, I don't want to go to a stage and say that because it's not true. I just learned, and I'm not confident enough to give the explanation. But yeah, keep that in mind, because this is the takeaway. Learn your models, learn what you're doing properly, and you will do amazing science. But it's not, there's not a magic button. There isn't. Yeah. Hola.
It's the first time I see a presentation so detailed about how is a neural network. And it's a thing that I am a bit confused because you are saying, okay, I am linearly combining non-linear functions.
Yes.
That's a convolution.
Yes, actually, a convolution is a neural network, but it's smaller.
No,
Oh, yeah. The
in a basic neural network, what you are doing actually is a convolution.
Yes. But it's one of the things that we do poor, is we call a dot product. Then it's actually a convolution. Actually, if you read papers about CNNs, it's like we don't have the notation because we have been using the convolution notation for neural network. So each paper has its own notation because we have been doing wrong for a very long time. But yeah.
Okay. If there are no more questions,
Cool.
the only thing is the next talk has been cancelled.
Oh.
Well, we
Oh.
have more time.
Yeah, I know. Yeah. No, thank you. I've done my work here. No. We can talk. Yeah, maybe I stop it too.
Before you mentioned the CNN to training some text data.
Yeah.
So I'm use the LSTM to read.
Yep.
I think this performance is much better than the CNN.
Yeah, I totally agree.
CNN is just training some image. Very bad.